Hi everybody, this is going to be our note for 5.3, slope. Now I know this says this is lesson 1, that's because in the past I used to teach this first, but I decided to do partial and direct variation instead. Now this topic is, we've kind of seen it a little bit before, we're just maybe calling it a different name before, but this topic is something that you'll need for this chapter and next chapter. You'll need it for, your exam as well, and you'll also need it for grade 10, and you'll see it in grade 11 and in grade 12 too, but it's expected by then that you'll know what it is and how to calculate it. So slope is a measurement of the steepness of a line. So the way I kind of described it in class, if we have like a person here, maybe like a lazier person like myself, where if we have the choice between going up this hill or this hill, which hill would the person who is lazy rather take? Well, I think they would take this one because it's less steep. This one is much steeper, maybe not much steeper, but it's steeper, so it's more effort to have to go up this slope here. So slope is a measurement of the steepness of this line. The symbol that we use for slope is m, and we've seen this before. We called it before the constant of variation. Well, it also stands for slope now. So there's a few words that are kind of synonymous or that are synonyms of constant variation and slope. And we can calculate slope in 3 different equations. We have m is equal to rise over run, which we see more for graphing, or m is equal to the change in y divided by the change in x. And what this really means is these symbols is it means just this. So the triangle means change in, which is really like the difference. So if we have 2 coordinates, we'll be able to calculate this, but we'll get to that later. What slope really is, it's a ratio of the rise to the run. So what do we mean by rise and run, like we kind of saw here? Well, this is what the y2 minus y1 means, and that's this delta y here. It means change in y. It's the vertical distance between 2 points. So this is a little 2 here and a 1. Note that these aren't exponents. These are just to note that this is like the second y and this is the first y. That's why we call that a subscript. So it's not an exponent, it just is kind of telling us which number y is this. So then we have change in x is the same thing, x2 minus x1, and this is the horizontal distance between 2 points. So remember on our Cartesian plane, we were using x and y. So the horizontal distance is changing on the x-axis because it's going left and right. And our change in y is in the horizontal, or sorry, the vertical going up and down because our y-axis goes up and down. So the ratio of the change in y to the change in x is often represented by the letter m. So very similar to our constant of variation, we can kind of put all our names down here that we know so far. So we know it's constant of variation. We'd also might know it as, we're going to see later, called rate of change. We also might know it as slope now. So if a question or a textbook or anything refers to any of these things, we're all referring to the same letter m, which is the change in y over the change in x. So when determining the rise and run from a graph, because I said before that this rise and run equation is mainly for graphing, when determining the rise and run of a line from its graph, you must know that if we're counting units in the upward direction, upwards, this gives a positive rise. So going upwards, like in our Cartesian plane here, going upwards is in the positive direction. Counting units in the downward direction gives a negative rise, which is kind of an oxymoron, but they just mean that it's going downwards instead, just like in the negative direction of the y-axis. We can think of counting units to the right gives a positive run, just like on the Cartesian plane. Moving to the right on the x-axis is positive, and then you can guess going to the left is negative. Now the way that I usually teach it is, I find that students get confused with the left and the right, which is normal. I think anyone would have that problem. So I like to think of up and down as the easy ones. So I always say that whenever we're counting the run or the horizontal distance, we always go from left to right. And then if we have, a negative slope, then it might go downwards, or it could go upwards from this point. But always go from left to right, and then the positive or negative refers to the up and down. But we'll get to that a little bit later too. So just by looking at this now, in this example, the following diagrams represent 3 different ski hills. Calculate the slope of each ski hill and rank the hills in order of their steepness from least to greatest. So remember our equation. Our equation is m is equal to the rise over run. So we can calculate this by calculating the vertical distance divided by the horizontal distance. So we can also see that again as the change in the vertical distance divided by the change in the horizontal. So try finding the slope here, and then we'll check our answers in just a second. Okay, so we're going to do, our equation is, rise over run. So the rise we're going up here is 60, and the run is horizontal distance, which is 70. I divide those two, and of course I didn't have my calculator ready, but now I do. So I get a slope of 0.86 by rounding it to 2 decimal places. So that's the slope of this ski hill. For the next one, for B, my equation again is rise over run, not ruin, run. That's the letter N. And then we get 60 divided by 110. So looks like it's going to be less steep. So we get a steepness of 0.6. So we'll put a 0 there just so it's to 2 decimal places as well. And then for C, we have the rise over run again. And we have 80 divided by 100, which you see as 0.80. So by looking at these numbers, A is the most steep because it has the highest slope here, and then C, and then B. So they want it from least to greatest. Least is B, then C, and then A. So the bigger the number, the more steep the slope. Example 2 says a hill rises 2 meters over a horizontal run of 8 meters. Then there's another hill that rises 4 meters over a horizontal distance of 10 meters. Calculate the slope and determine which is the steeper hill. So we can just make a diagram of these 2 hills if we want to. So we have a hill that is 2 meters, it rises 2 meters, and a horizontal distance of 8 meters. So that's the first hill. And then we have a second hill which is 4 meters and 10 meters on the horizontal. And 4 meters on the vertical, sorry. So just draw a diagram just to kind of see what we want here, or to see what we need to calculate. We'll calculate the slope of each one. We have 4 divided by 10, which is 0.4. And then we have 2 divided by 8. The rise is 2, the vertical, and the run is the horizontal, which is 8, which is going to equal 0.25. So the slope is 0.25 for this one, 0.40 for this one. Therefore, the hill with a rise of 4 meters is steeper. If you wanted to, you could label them A or B. If you wanted to, then just say, oh, A is steeper than B, but I just went with that description. So again, just doing the vertical distance divided by the horizontal distance. All right, count the units on the grid to determine the rise and the run. Calculate the slope. Is the slope positive or negative? So this is what I said before when we're calculating slope with rise over run. We run in the horizontal distance, and then we rise upwards. So what we can do is say that we can say that slope is equal to rise over run. So it doesn't matter which one we do first. So we started at A here and we're going to B. So I'm going to run 2 squares over. So the run is 2. And then the rise is 1, 2, 3. If we wanted to, we could have gone in the other direction. We could have gone the rise first, and then the run, And we get the same answer of 3 over 2. So is the slope positive or negative? So by looking at it just like we did with our scatter plots and our line of best fit, as I move from left to right, I see that the line is going upwards. So we say that this is a positive slope. Example 4 has us doing the same thing, but we notice that the line is kind of going downwards. But let's just do our slope first. M is equal to rise over run. This time notice we're going downwards. 1, 2. So this is going to be the negative rise because it's going downwards. Then I run 1, 2, 3. So the run is 3. So this is going to be our slope. Is it positive or negative? Well, we have a negative because we had to go downwards. But also from our scatter plots, you can see that as I go from left to right, the line is going downwards. So that tells us we're going to have a negative slope. So really quickly, I was talking before about just make sure you go left and go up or down. There are cases where we have to go right and it's, or sorry, go the left direction and it's negative. So for example, if I did the rise over run this way instead, where instead of starting at C, what if I started at D instead? And then I went up 2, so the rise is 2, and then I went to the left 3, 1, 2, 3. Well, the left direction is the negative direction, so we get 2 over negative 3, which again, we can just move that negative to the middle of the fraction if we want to. So we get the same thing. But again, I find that students, when they go left, forget that it's a negative. So I think instead of going downwards as negative and then always run to the right, I think causes less errors. So that's just my opinion, but you just have to remember positive and negative slope, and even if you can just see it and see the difference, that's also okay. But we should be able to see like going down is negative. So for detecting positive and negative slopes, if we see a line that goes upwards from left to right has a positive slope, and a line that goes down from left to right has a negative slope. For these next two examples, we're going to have a couple special cases here. So we're going to find the slope of a vertical and a horizontal line. So example 5 says plot the points A, 1, 1 and D, 5, 1 on the graph provided, then connect the points to form the line segment AD. So I'm going to just label these 1, 2, 3, 4, 5. This is the x-axis, this is the y-axis. Y-axis going up and down, x-axis going left and right. Then I go 1, 2, 3, 4, 5 here. So I'm going to plot these points, 1, 1, 5, 1, and then I could get something with a straight edge and join these together. So this is called AD. So determine the rise and the run of line AD. So if I have the rise here and the run. So the rise, are we going up and down at all? Not really. So we have a rise of, I guess, 0 because it's not moving up and down. It's just kind of staying the same. And then my run in this case is 1, 2, 3, 4. So my run is 4. So if I were to calculate my slope now, m is equal to rise over run. I always put an e there. Which is equal to 0 over 4. And 0 divided by 4 on your calculator is, of course, 0. So our conclusion about the slope of a horizontal line, the slope of any horizontal line is 0. That's because it doesn't matter what the run is, but if the rise is 0 on top, well, anything divided by, or anything, 0 divided by anything is just 0. So a horizontal line has a slope of 0. In example 6 here, we're going to plot the points B11 and E15 on the graph provided, and then connect the points to form a line segment BE. So we'll do the same thing. I'm going to label this graph 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. we have 1, 1 here, and we have 1, 5 up here. So we'll join this together with the line, and we'll call this BE. So now we'll determine the rise and run of these. So like the rise here, seems like it's kind of flipped. We have 1, 2, 3, 4. So we have a rise of 4. Then we have a run of, well, I'm not moving left or right here, so we have a run of 0. So we'll calculate the slope. M is equal to rise over run. Then my rise is 4, and my run is 0. So check on your calculators. 4 divided by 0 is obviously, well, let me check for it and not leave you in suspense. Whoop. 4 divided by 0 is error. We get an error. So why do we have an error with 4 divided by 0? Why isn't it 0? So the best explanation, I guess, is if we look at this, this is still a fraction, isn't it? And what is a fraction? A fraction is a part of a whole. So if I have something like, 2 out of 5, there's 5 slices of pizza and 2 of them were eaten. This is 2 of, or part of, 2 parts of 5. So we can divide this. But how can I have 4 parts of nothing? I can't have 4 parts if there aren't anything to exist. So I can't really take those things. I can't have 4 of nothing. So we call that kind of an error. We just can't do that in math, because you can't have 4 of nothing. So that's why it has an error on your calculator. So what we say here is, because we can't divide anything by 0, I'm just going to go to the next page because it kind of sums it up. Our conclusion about the slope of a vertical line is that the slope of any vertical line is, we say it's undefined. Well, what does that mean? Well, if you define something, like in English, it's like you're stating what it means. So something being undefined means we cannot give it a definition. We can't give it a number. We can't say what it is because it can't be done. It doesn't exist. So any slope of any vertical line is undefined. So those are 2 special cases where a horizontal line will have a slope of 0 and a vertical line will have an undefined slope, meaning we can't determine the slope of a vertical line. So a couple more examples here of just calculating slope. So for 7a here, we have 2 points. So we can do rise over run. That's mainly what we've been doing this time, and we're going to be looking at the other equations a little bit later. So I'm going to first see my first point and my second one. I'm going to start at this one, and I'm going to go from left to right. So I'm going to go 1, 2, 3, 4, until it lines up with the other point. So this tells me my run is equal to 4. And then I'm going 1, 2, 3, 4, 5. So my rise is 5. But is it 5? It's more negative 5 because I'm going downwards. So this tells me my slope is rise over run, which is negative 5 over 4. And if you want to turn that to a decimal, you can, but I'm actually no, keep it as a fraction actually. We prefer it as a fraction. And why do we prefer this as a fraction? Because if I'm giving you 1 point, and I want you to find another point, well, we want to be able to calculate the rise over the run. So like if I give you a point, let's say up here. If I say find the next point, we can still follow the pattern of going 1, 2, 3, 4, 5, and then running over 4. 1, 2, 3, 4. So like these 2 lines would be kind of parallel to one another. I could find the next point here by going, by continuing this pattern of rise over run. Anyways, let's do the next one where I have this time I'm going 1, 2, 3, 4. So that's a run of 4 again. And a rise of 1, 2, 3. And since I'm going upwards, I'm going to have a positive slope. Notice the line's also going upwards. So m is equal to rise over run. Rise is 3, run is 4. We can leave it like that. That's fine. Also, we also know it's 0.75. All right, example 8. the ramp at a loading dock rises 2.5 meters over a run of 4 meters. What is the slope of the ramp? I think we get it by this time. We're just going to have m is equal to rise over run. And then our rise is 2.5. Our run is 4. So 2.5 divided by 4 is 0.625. So that is our slope. So that's it for the 5.3 note. Please try some of the homework. Again, this is a very important topic, and I know it might seem like it's not too bad, we're just counting. We just have to try some of the homework to kind of solidify our learning. So try the homework, and then have a good day, and thanks for your time.